So we have a problem in the homework based on some data from the New York Stock Exchange and then some observations on a particular day. So on the basis of the facts above, about 30% of the stocks traded in the New York Stock Exchange went up in the same day. So we're going to take a random sample of some stocks. We grabbed 64 stocks. On that day, 26 of them went up. So we have to see, how does 26 out of 64 compare to 30%? So what we're doing is we're conducting a study, hypothesis test, to check if the proportion of stocks that went up is significantly more than 0.3, which is 30%. We're asked to use a significant level of 0.5%, 0.005. So let's just double check the important information here. Let's get a highlighter. So 9 out of 30 stocks increase, so that's kind of some basis information. And then a financial analyst wants to assume that 30% of stocks traded on a particular day increase in value, right? So they went up. We have a sample, and in that sample of 64 stocks, 26 went up. So what that means is our sample proportion, that's what we call either P hat, sometimes it's called P prime. So ours is 26 out of 64. And so if we whip out a calculator, see what that looks like compared to 30%, 26 out of 64, we get 40%. Hey, that seems quite a bit higher. Okay. So is it significantly higher? So now we have a measurement of what does it mean to be significantly higher. And the measurement for us, Magic Pen's freaking out, there we go, is that to see how unusual this is, we're making 0.5% our mark of being unusual. So if we're expecting 30%, what does it mean to get a random sample of 40%? So we're going to run a bunch more samples and see what the sampling distribution looks like. So that's what we have to do next. So the things we have to go by is we're assuming the null hypothesis is the population mean, or proportion in this case, and that's 30%. We're comparing that to 26 out of 64, which is closer to 40%. Is that high enough to say that it should be higher than 30%, or is it just close enough in general? Next, to do that, we're going to run a sampling distribution, and we're going to use this sampling distribution based on a test for a single proportion here at StatKey. To do that, we need to edit the original data here, and we want to put our count of 26 stocks went up out of a total of 64 stocks observed. All right, so there's our 40.6% over there. Next thing we need to do is adjust our null hypothesis. The null hypothesis is that it should be 30% or 0.3. So we have to enter our percentages as a decimal, and our fractions ultimately need to get turned to a decimal also. Once we've done set our sample and set our null hypothesis, then we just start generating random samples. So remember, what does it mean to do that? So every time I hit generate a sample, 10 samples or 100 samples, this group of 64 is reshuffled as a deck, and then we pick one up, we look at it. Was it an up stock or a down stock or a stay the same stock? And we make a note. So when we redrew from this particular deck, the second time we drew cards from that deck, we got 18 out of 64 went up. And then we'll do it again, and this time 21 out of 64 after we reshuffle the deck and draw. And we're drawing with replacement. So we look at the card, we put it back in the deck. And so every one of these is my new sample. There's the 21 out of 64, here's the 18 out of 64. I can generate 10 at a time. And I can see this one right here was another 21 out of 64. And it's possible we could end up with 13 out of 64. And then again, we have 23 out of 64. We could do 100 at a time. So here I have a whole bunch that measured at 18 out of 64, 19, 20, 21, and so on. So we're just building a histogram here. A histogram is a distribution. In this case, the distribution, every one of these dots is the proportion of a sample. So I reshuffled my cards, I drew out one at a time, looked, put them back, got 64 cards. I found one was 20 out of 64. I found it possible to get 31 out of 64, so almost 50%. Okay. So I'm going to generate 1,000, and 1,000 more, and 1,000 more. So we're building a sampling distribution. Now, we're expecting that most stocks are going to be around about 30% of the stocks we look at are going to have are going to go up. So any one of these samples I pick on here is pretty close to 30%. Sometimes we're way above 30, sometimes we're quite a bit below 30, and that happens naturally. There's always variation among samples. So I have over 7,000, that's pretty good. Next thing, I need to decide what kind of test to do, left tail, right tail, or two tail. So back to the problem at hand. We want to conduct a study to see if the proportion of stocks that went up is significantly more than 30%. So that right there, that statement's my my alternative hypothesis. So HA for alternative is going to be that the population proportion is actually greater than 30% or 0.3. The null hypothesis is either going to be that P is equal to 30%, or I could take the opposite of greater than, which would be less than or equal to. Okay, so we could go with either of those here. I'm going to write it down this way. So I'm doing a right tail test is what this tells me. All right, so back to my sampling distribution, right tail test. The next thing I want to do is say, okay, let's take the first random sample we started with, which had a proportion of 40.6% of the stocks went up. So I need to change this right endpoint, this cutoff value, to 0.406. And what this tells me is that the computer then looks to say, okay, how many of the 7,212 random samples I made based on the original, how many of them were about 40.6% or higher? And this tells me that 4.9% of them, that's my p-value right there, 4.9% of them were greater. So this is the probability that you take a random sample of 64 stocks, you're expecting 30% of them to have gone up. We found that about 5% of them were at 40 or higher. Now, 5%, that's not all that unusual. That's going to happen some days. So what that means to me is 40% isn't unusual enough, okay? So that's just my gut intuition on it. Now, I also have a more hardcore test because I was told to use a significance level of 0.5%. So that's my alpha. So that's the last thing I do here besides interpret it. Magic pen. So alpha, we want to compare alpha to the p-level. Now, if we want to reject the null hypothesis and accept the alternative, then we're hoping for an unusual event. An unusual event means that your alpha, your significance level, that is going to be bigger than your p-value. And in this case, alpha is 0.005, and my p-value is 0.045. And I think that's what it was. Or was it 49? 49. So I fail to reject then. This is not all unusual. So fail to reject. There's not enough evidence here to say it's greater than 30%. Okay. So what if we went with a 5% significance level? Then we were just under what it means to be able to reject. So then we could say, hey, let's reject the null. We're far enough away, but just barely, right? 4.9% versus 5%. But here we were told to be even more, more selective, basically. So let's see what it looks like to finish this problem online. So in our homework, I was asked to calculate a p-value based on this simulation, and I got 0.049. And every time you run this, it'll be a little different. So I'm just going to run it again, see what I get the next time, just for fun. So I'm just going to reset it. I have my 30% here, 26 out of 64, or about 40% there. And then I just run 1,000 and more samples. So I did 7,000 last time. Let's take it up to 9,000 this time. 10,000, what the hell? And then it's definitely a right tail test because I want to see if it's possible that many groups of 64 stocks will be more than, will have gone up more than 30%. I need to set my critical number here, and that is 0.406. And this time I get 4.8%. It's in the ballpark of last time. And these are simulations, and it's like drawing cards out of a deck. You never know what's going to happen. So there's going to be some variation in the p-values. I tried to set the computer to take a wide range of p-values, but sometimes I miss things that can happen due to just random chance. So if you think you did this right and you have a p-value that's reasonable based on the randomization test here, then hit message your instructor, send me what you typed in, maybe send me a screenshot of what you got in StatKey, or just describe what you did. All right, so the p-value is greater than the significance level, which means we fail to reject the null. We can never accept the null because that means we've proven it, and we can't prove anything, right? We can only fail to accept, or fail to reject it, or reject it. Now, if we do reject it, then we kind of like to say we can accept the alternative hypothesis, but it by no means proves the alternative is true. It's just we have some evidence of it. All right, did we find sufficient evidence? We did not. So there's not sufficient evidence. There's two that say there's not. So let's see, which do we want? There's not sufficient evidence to warrant rejection of the claim that the proportion of stocks that went up is more than 30%. Okay. That looks good. There's not sufficient sample evidence to support the claim that the proportion of stocks that went up is more than, okay, what did I miss? Those look. There's not sufficient evidence to warrant rejection of the claim. No, we are rejecting the claim. Okay, so that one's definitely wrong. There is not sufficient evidence. Yeah, so the language, you have to be very careful. It's subtle tricks. There's not sufficient evidence to support the claim. Yeah, we can't accept the alternative, so we don't have enough evidence. That's got to be the one there. All right, so hopefully that my p-value gets accepted here. That's going to be the only questionable thing if you set everything up right. Submit and hope for the best. And my p-value was good enough today. Cool. So again, if you tried this and you think your p-value is good enough, then just hit message instructor and tell me about it. Maybe send me a screenshot of your randomization test here, and I'll get back to you. Take care, do good math. I'll see you in the future.